Hello, we are back. How's it going? Before I start, just so we have it on record, if you look at these two tweets, we've claimed that we've beaten Pokemon Red with online RL. That is the claim. So, where is it? This thing. Where was the darn EMAD tweet? Typical EMAD, misrepresenting shit. Oh my gosh, how much does he tweet? Okay, there we go. We did not claim to solve Pokemon as a benchmark. This is not what we claimed. So for Tim here, this criticism is a criticism of a claim that we do not make. So there we go. Now we will get on to real work. Welcome, YouTube folks. What we're going to be doing at the moment is trying to get this kernel working, this CUDA kernel working for this advantage function that is the centerpiece of the new RL algorithm that I'm doing. And I'm going to have to figure out what's wrong with this. So apparently I'm just passing it the wrong signature. Let me see. So tensor, 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 tensor. Wait, eight tensors. 1, 2, 3, 4, 5, 6, 7, 8. 8 tensors, right? No, why do we have more than that? Hang on, why do we have more than that? Advantage kernel. 1, 2, 3, 4, 5, 6, 7, 8, 9. Int. Why does it say arg9 is an int? 2 ints. What? Oh, there's an arg0. Okay, we're good. So it's 0 index. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, there are 9 of these. Okay, and then we do 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 2 ints. Int. Float. And then there's grid and block. Really? The heck is wrong with this? Is this not how you'd call this? With grid and block? We'll have to see. Should be encapsulated. Okay. Corrected. Okay, so then this gets passed from, I don't know how this gets computed, but whatever. Let's see if this does it. Okay. That's something. 14% misc, but this runs now. Here. Actually, why don't we just, let's see if this matches perf as well. Tune. Here, we'll do this. Ugh, Neptune's got too many depths. No, not this browser. Yay. We'll see how the curves differ. I'll be pretty impressed if this zero shots it, but I won't be baffled because honestly, CUDA for this is pretty easy. Like the more oh yeah, that's looking decent. But seriously, like the more I learn on like the low level dev side, when people are saying, "Oh, it writes CUDA kernels, it's so hard." No, it's not. Sillies. Simply just not that hard. I thought I had some runs I was looking at here. There we go. That's a CUDA kernel for you. That is a CUDA kernel for you. And that matches perf. Lovely. Look at that. Boom. Up to nearly 1 million steps per second on this. Just array programming. I think debugging these is a pain though, right? Yeah, debugging CUDA sucks. So I still wouldn't want to write like, you write kernels in it, right? You don't write whole chunks of stuff in it. Big CUDA programs would be a pain. Debugging sucks. But this is fun. It's totally fine. Now we have this. Do we want a fallback? We probably want a fallback, right? Let's go do the rest of the optimizations here. Probably ship a CUDA version of generalized advantage estimation if we wanted to. That'd be easy enough. So what we have is 15% overhead right now, right? And we have a whole bunch of redundant stuff. So like this. Wait, whoops. Let's go like this. Like this. And where's reward block? Experience block. Okay, all we have to do is reward block will be this. Mask block will be this. Buff is already done. Advantages is already done. Balance is done. Great. I think we just have a bunch of redundant stuff we can get rid of, right? Let's try this. Oops. Kill Neptune. Don't need Neptune on every run. Ward block NP. There we go. What CPUs are you getting with the new boxes? When we get them, 9950Xs. Okay, so this goes down to 12%. Custom is at 0. Hang on, how is custom at 0? Well, MISC is at... Is this fast now? Oh yeah, this is fast as hell. Yeah, we are good. We are absolutely good here. We're gonna ship CUDA kernels. I don't know, I might get CUDA fever and write even more CUDA. We'll see. Might just do some CUDA optim. Make everything even faster. Because this just solved the problem with this. What is the difference at the moment in performance? If I do this, we get 1.2 milli, right? 1.1, 1.2, something like that. And if I do this, 20%, not quite 20%, like 15%, I guess, perf dip maybe. Let's see. So we still have 5 extra percent miss. Learns 29, forward is 11, copy is 11 or 12, MVIS 15, 16, 17. I wonder if the model's just very slightly heavier now. It could be. It really shouldn't be, though. Well, I mean, we'll definitely get very, very close if we can just take this MISC down. Let me make sure I actually know where it is first. I want to be absolutely sure that it's right here. Oh yeah, we got 8% right here. 9%. That's pretty much all the over. Yeah, there's your 5% gap right there. Okay, so why is there a 5% gap? Square. Okay. Is this the operation right here? Hang on. 7% in custom. Oh, it's so close. This index right here. This is 5%. What about this? It's like, yeah, okay. So can I just do V loss equals, yeah, V loss. Is this the same thing? No. Times mask block dot sum. You have to do this one, I think. How's this? 6, 7, 7%, 8%. 8% versus it's a little faster. Do I want to just torch compile this mess? I also don't even have clipping on here yet, so I guess I probably want to compile this, right? We'll see if it's actually faster. Let me see. So new log probs, log probs. the frac. You always norm the advantage, right? Go. You don't need any of these things in the signature, right? You don't need advantage in here either. Stupid autocomplete. And this is all you need. Yeah, it is. PG. Okay. Had what, 12% in miss? Cannot access. Oh, you do need advantage. Prox KL. Come on, Torch. Is that even faster? No, it's not faster. You forgot the decorator. Okay. We just do this. I don't think this is any better. So that doesn't even help. just makes it take a little longer to start up, honestly. Yeah, it's no good. Man. Well, actually, I see something here we can do. And that we're going to actually remove this old. Remove this. Actually, we can keep it for now, in case we decide we want it. I think I see something here. Where do we use these? Get rid of this. Need clip frac. That saves a little bit. Does it? Saves a little bit. I don't know if it's worth that. clamp. Okay. Well, I guess then we have to do this little bit here. We're fighting over like such a little bit. Nah, 4%. Okay. P30 horizon. NLL loss. One dimension. That's not any better. Any better at all. I mean, I don't know why I would expect it to be fair. Kind of just screwing around trying stuff at this point. Hold on, maybe I masked first. Suspicious of this being faster. Slower, right? Much slower. Much slower. It's annoying how that works. Unless this, maybe. Let's try this. No, still no. Masks are annoying. Yeah, mask is really annoying. The issue is, hang on. It's come out of the policy. And then what's the mask come from? I know what the mask comes from, that's fine. The mask comes from the computed advantage, right? Speaking of which, I hope we still compute that. I think we would have to. Yeah, these three indices are going to mess it up. So I guess it's better to just do it the previous way. I mean, the perf overhead is like almost negligible, almost. Yeah, we're 1.1 mil here. We're at 1.2 mil here. Yeah, I think we're pretty darn close to negligible. 7% overhead. 10%, 7 or 10 or 11%, yeah. It's within like 5-10%. I think we can torture, I can torture myself over this for as long as I want, but for now this is pretty solid. Okay. I think, yeah, fixing the env overhead and such will be higher priority. But getting this algorithm running over 1 million is really nice. Oh, we do have to see how the overhead scales, unfortunately. That is going to be an issue. P30 horizon. Really not bad. Let me see if there's overhead up here or something. %. Yeah, it's way better than before. Okay, I'm way happier with this at least. So, actually, I think the first thing I want to do is just run this to see if this still totally screws up. We have, not this one. Where is this thing? I thought we had a nice window somewhere here. Isn't that right? Oh, here it is. This is it right here. I'm looking at it. You know, I have some hope for this. I definitely have some hope for this. I think it's going to take some re-architecting on Saturday or whatever, but I think we'll be able to get this parameter to behave the way we expect it to. $381. All right. So definitely don't do this for now, but this still works. And this works at over a mil. So we should be able to get something out of that. I'm going to mess with that kernel later. Gotta do this annoying NQL store. Okay, we will merge that. Seriously? Super annoying. Okay, let's merge that real quick. That would have been a disastrous merge. Boom. Okay. Did you just zero shot a CUDA improvement? With rock or whatever? Kind of, but the thing is, like, it's not that impressive. Look. It's like, oh, CUDA's big and scary, right? It's just C. So I already had Python code that looks, I mean, this is what the CUDA kernel looks like, okay? And this is what the Python looks like. It's almost identical. So yeah. CUDA is not that hard. It's literally just C that runs on your GPU. Anyways, P3O is now basically the same speed as PPO, at least for short horizons. We'll be able to do some optimization more on top of that, but this should be good. Now, the only thing that's annoying is we do have to update the containers to be development instead of base, which is obnoxious, but no big deal. I want to get some stuff running on this. Let me think how I'm going to do that. And we're gonna just have to ship the new container or like use it. And it's been ridiculously busy lately. I've like barely had time to shower or eat properly. But we are getting stuff done. Can I just build this? I think that we will probably, whoops. What the hell? Oh. There we are. Do I have anything going here? Guess not. Nothing in there. Good. Rebuild on box 0. So we can run this. You have to build this thing manually, don't you? Yes. Oops. We'll take a few minutes to rebuild these here so I can play with them. And we'll see how this does. Yeah, though, you definitely like the training loop, the Python overhead and the kernel launch overhead and stuff is just disgusting. There's substantial performance to be gained by like fusing stuff together. I don't know, maybe we'll do some kernels at some point, who knows? Maybe we'll do some kernels. Pokemon announcement is doing well. Well enough. This takes forever. Well, the idea, we will just get this running, and then I'm going to port some code for some collabs. Port some code over to some stuff real quick. Then this will be good. We'll have gotten P3O relatively perf optimized today. We have our first CUDA kernel in Puffer. I'm sure we'll have distribution hell with those, but we'll figure it out. I'll have to look at what PyTorch does. We'll see. Maybe we do Cython fallbacks for Puffer stuff, we'll see. But I think probably we'll do C fallbacks. I don't know yet. How annoying is it to get CUDA to run on the web? It just wouldn't work if you're on a laptop that doesn't have that, right? CUDA's NVIDIA specific. So I guess it's web GPU, not CUDA. It's a pain in the ass. I think we'll leave our little puffer demos the way they are. We'll focus on the RL stuff that matters. Get this new algorithm tested nicely. Because I'm actually wondering if it's going to get more sample efficient just because we made it faster. Actually seems kind of possible. With the way that this is set up. That'll at least give us a much closer comparison to PPO. And then from there, I mean, there's still some things on the algorithm, to be fair, that I'm not happy with. So. And I think regardless, the things that I do will also make PPO better. So we'll do that over the weekend, most likely. That seems like a good use of a Saturday. I definitely need to clean up the repo and prune some stuff. Get the clone time fast. All right. Unknown or invalid runtime name NVIDIA. What in the heck? No such container. We have CUDA 12.4 support here. 550 drivers, right? .4. No such container. -V. What the hell's wrong with this thing? There it is. Cool. Okay. It should run fast. Breakout mode. Build.ninja. Ugh. Oh, it is getting picked up by Torch. 1.2 milli. Use P3O. We'll do this. 1.1 mil. Alright. We were happy with that. Fault. Auto. That's good. We're happy with all this. This is good enough for now. Emacs. Sweep tune tag. Go P3O CUDA. And train.use P3O for install Neptune. Okay. I just need my token. We will have this sweep going. Yay. So 1.2 mil for this new run. It's kind of nutty. Oh yeah, you're getting the overhead twice because it's 2 update epochs. Yeah, this is nice. It's very nice. Is it supposed to do 50 mil like that? And maybe it is. Fine. I'm happy. This is fast, million step per second training. At least. New algorithm. New sweeps. I'm good. I still have to do some porting work, unfortunately. I get to sleep. It should be pretty quick if I can just get it set up fast. Where is it? Not this page. Oops. I think we need to go to, where's it, this one? Yeah, right here. Frickin' Conda. Is there no, damn it. They don't have a freaking file for this. I mean, I guess they have requirements text with everything freaking pinned. It's literally not even available anymore from this. Let me do if they're set up. Are you gonna create a CUDA env? If so, no, I did. It's not an environment. I just shipped it actually in dev. I need to go through it because it's just a grok port of my Python code. It's like very basic, but it's good. Let me find it. So this is just a CUDA implementation of a new advantage function that is the key piece of a new algorithm I'm developing. And it was too slow when I had it in Python, so I just put it on the GPU. And now the algorithm is pretty much as close as it can be to PPO speed. And we're going to get to run some experiments on this. This is already running live. And now all I'm doing is I'm porting over some of our perf enhancements from this to other stuff. As for the EMs we're building, like, now that I'm thinking about it, technically we could use a little bit of CUDA for stuff if we had to, but the launch time for kernels is pretty rough. So I think we're gonna probably push CPU as long as that continues to make sense. We can go to CUDA if we need to, but I don't think it'll be needed really. SJE. Pokemon release has been reasonably well received. Nice. $117 followers already. Very nice. Hey, welcome. I think this isn't terrible for day one. I mean, it didn't like massively blow up, but I mean, we'll continue to get throughout the week as we post more visuals, right? Is it still on there? Oh yeah, it's still there. Oh yeah, 93 on here. That's pretty good. Oh yeah, there's some good comments. Yeah, that's good. I'm like half, yeah, and that's the other half. But still. Reddit's rough. I just shipped a CUDA kernel to Puffer. The CUDA kernel is much faster. We now have the sweeps on the new algorithm running very fast as well. Oh, is this to get around overhead problems? Yeah, the C implementation of this particular advantage function was not fast enough. Why CUDA over Triton? I don't know, man. Why rice over pasta, you know? Pasta tomorrow, maybe. We'll see how well this does. Yeah, it's already got a near solve in 100 seconds, so that's something. I'm pretty sure this is using the algorithm, right? I mean, I guess we'll find out. PR, yeah, it'd be nice. I looked at it, it seems reasonable. I just like pushing stuff to 2.0 just causes me problems. If it's not like a direct fix to something, it usually just causes me problems that I have to like then go and be like, that's somebody important complaining that I really need to not have complaining about stuff being broken. You know? Right, multinomial in CUDA. I mean, we could, yeah. If it's substantial enough overhead, then yeah, it would make sense. The really obnoxious thing is that you have to provide a, you have to write it twice, right? Because it doesn't run CUDA if you run it on CPU, so you need to have a fallback. And they have to match. This runs. Do I have a fork of this? Do I have a fork of this? I forget. That would make it a lot easier. Oh yeah, you dumbass. Well, I'll be quicker now. I'm just getting tired. There we go. Job for Triton. Oh yeah, this is the OpenAI thing. Is it good? What does it do that CUDA doesn't do? Well, Torch Compile doesn't do jack shit, so... I mean, literally, as far as I've seen, we get very, very little out of compile on everything I've tried it. Is this going to be something I will like? Why do I think this doesn't look like something I'm going to like? Let me go find the... Why do I think that this is not something I'm going to like? What is it that like is saying this? Let me see. Why does this look worse than normal C? Yeah, that's probably what it is. This looks kind of ass, not gonna lie. I mean, I was like, I don't know, Brock, write me some CUDA. And then I look at the code and I'm like, oh, that's dumb. That's so easy. CPU AMD. CPU NVIDIA. Eh. Why couldn't they have done that just like... Why couldn't they have just made my CUDA code work on the CPU instead? I mean, it's actually like the funny thing about it is, like, I've been really enjoying getting closer to the hardware because just everything is easy. Like, seriously. Like, I've been writing C and like, I've been writing enough C that I look at CUDA and it's just, oh, this is just C. It's just really easy C. I mean, I'm sure debugging sucks, but that's like a tooling problem, right? I mean, we can look at the kernel. It's really basic. Like, here's the kernel. I added all these buffers in so it wouldn't have to do any allocations as well. I haven't either, but then today I had one, right? I need to write a loop. The loop has conditional logic in it, right? The loop has conditional logic in it. And it's just C. It's like, oh, I have an operation that has to be applied to every row of a tensor equally, but it needs to loop over the elements in the row, dynamically. Okay, CUDA. Done. This is literally right here. This is the only like CUDA thing in here. You don't have to think in terms of anything. Literally, look, this is the only CUDA right here. It's just getting your index from the thread and block or whatever. The rest of this is C. I'm pretty sure you can just paste this and it compiles to C. So like, literally, I could just paste this into another function, and then I could pi bind it, and you'd have a C fallback version, right? Because that's a C fallback right there, and it would just work. And you just write a for loop, and then the GPU, on the GPU, CUDA does the for loop for you. That's literally it. That's like brain dead easy. Making the kernel fast. Well, just writing any kernel at all is immediately like way faster than even my C implementation, right? Diminishing returns looks like this substantial block of code is no longer causing any overhead. Right? Like this substantial block of code no longer shows up on the dashboard when I profile it. I cloned the wrong freaking thing. I didn't. You can go ahead and look at it. But I mean, for now, we're maybe 10% off of. We're like 10% off of the perf of PPO, and it looks like most of the difference is just coming from the like slightly. It's like a masked loss function, and the masking is a little bit expensive. It's also a different loss function in general. It's a Gaussian NLL. Okay, now we start pasting. We start pasting shit in from the current branch. And then these collaborators will have the fast stuff. Clean PufferLib. See ya. And nah, I'm good. Yeah, I don't blame you. I do not blame you, my friend. We should probably just copy him this whole thing, right? We'll just give him the sort keys one for now. Probably just do this. They're so annoying because it's like decent chunks of this have changed. Okay. And the only other thing I gotta do is in PufferLib. Oh, I gotta see where it is in here. ID. See what this does. Dude, what the heck is this thing? Come on. I hate Hydra. Is there no end batch size? Buffer. How does this work? Pile mode. Did they delete it? Why? My leg is just like falling asleep completely to the point that, hold on. I stand up a second. This is mostly better. Weird, I don't know. Okay. Where do they get the freaking config from? You're gonna drive me nuts. CFG. I hate Hydra. I do not like Hydra Sam. I do not like green eggs with ham. Fucking hell. How do you even find anything in here? Puffer.yaml. They don't have an end batch size. Async factor. No. Mini batch size. They don't have num ems. Oh, this is this thing that. God damn it. I do the things I do in Puffer for a reason. When you change them, stuff breaks. It's not my fault, damn it. If you're gonna change stuff and you break it, and you make it impossible for me to fix it, it's not my damn fault. Alright? Where do we make the backend for this thing? Does the trainer make the backend? Ems is 48. Agents per batch. Now we need this one. Sort training data. We just take this one. What happened here? Oh, I know what's wrong here. Trying to see where they call this from. Tools, train. Maybe it's just in there. Oh, I just forgot this. Okay. Branch. Make a PR. Commit ahead. This is a clean PR. Request. Turn this over. Alright, that's done. Very, very nice. Whew. It's 9 p.m. and that's been good progress, I'd say. How are we doing here? Let me check one thing and then I'll show some experiments before bed. Whoops. I guess this doesn't matter, nothing private here. Cool. Now we will look at, make sure our experiments are going well before we call it a day. This is what we had before. And now. Look at this. Oh, burrito front somewhere. I assume that I actually have the right flags on this, right? Burrito front. 100 seconds here, almost solved. So we'll see how well this does. But this is looking like it's very likely going to be on par with the original or better. We will see. This is already quite good. 100 seconds for 8:38. Now, I just want to make sure real quick that we are actually running the thing that we think we're running, because that would be a real shame. So let me make sure I actually train.use P30 true. All right, we're using P30. So, there we go. How do our curves look for this? Oh yeah. It's kind of crazy, honestly, how close this is to being on par with PPO. I guess we did just make PPO a little bit faster as well, so we technically will have to rerun that. But before, yeah, it was like 180 seconds. Now we're already down to 100. Let me see. I think it was this one was the best one with PPO. Yeah, here we go. So our best, no, not this one, I guess. This one. $180 seconds. This one. I'm trying to find our best sweep. There it is. So 80, 90 seconds for a solve. Call it, yeah, 85 seconds, we'll call it, for a solve. Was our best previous. This is with PPO, and then this is training at about 1,200 steps per second for the fastest ones. So it's still going to get a little faster than this. But the new ones, with the new algorithm, the best runs are so much slower, interestingly. Oh, that's weird. The best runs are way slower, but are still solving in not that much wall clock. Well, we will keep going on this. Eventually, this is just going to get to the point where it's ridiculous, and we're like insta-solving this, and we're going to have to throw it on all the other environments. But yeah, I think I'm pretty happy with the way this is going for now. So I'm going to get some rest. It's been a heck of a few days here. It's been busy. I'm looking forward to just getting more solid dev in. More solid dev. But for people watching, if you're interested in all this stuff, you know, we released this awesome Pokemon RL stuff today. You can check this out here. We've been shipping in dev, tons of perf updates. We've got new M's that are getting merged in. We've got new algorithms for RL in development. If you want to check all that out, it's at puffer.ai. All the links are here. If you want to go ahead and start the repo, really, really helps us out. And other than that, you can join the Discord to get involved. And you can follow me on X for more RL content. Got a blog here, got some more blog content on the X you can't find anywhere else. And that's about it. I will be back probably just tomorrow morning working on more stuff on the new algorithm, more experiments, and the like.